Hi, my name is Thomas Beltran, and with my partner Juan Rodriguez, we are going to make you a presentation about this infography about building a bakery database using ER concepts. Here we have the concept of an entity. An entity is a real-world object that is stored in the database as a table. In this case, examples of entities are customer, order, product, and ingredient. Each one represents an important part of the business and becomes its own table where a database is stored.
Okay, next we have attributes. Attributes are the properties that describe an entity and they become columns in table. For example, a product as attributes like product name, price, and stock. An order has attributes like order date and total. These attributes help describe each record in detail.
Okay, then we have relationships. Relationships show how entities are connected to each other and how they interact. For example, a customer places an order, and order contains product, and a product uses ingredients. All these connections are represented in the ear diagram.
Yeah. After that, we have cardinality, which defines how many instances of one entity relate to another. For example, one customer can have many orders, which is a one-to-many relationship, as one order can include many products and one product can appear in many orders, which is many-to-many relationship.
Well, next is the primary key. A primary key is a unique identifier to each record in a table, which means no two rows can have the same value. Examples include customer ID, order ID, and product ID. This helps prevent duplicate data in the system.
Then we have the foreign key, and the foreign key, a field and reference the primary key of another table, creating a connection between them. For example, the order table stores the customer's ID, though know which customers made the purchase without repeating all the customer information.
Okay, after that, we have the weak entity. A weak entity is one that cannot exist without another entity. In this case, order detail is a weak entity because it depends on the other. It represents the products inside each other, and without the other, it has no meaning.
Okay. Related to that, we have the identifying relationship. This type of relationship connects with indeed Dwight's parent intent and give to identify. For example, the connection between order and order detail ensures that each detail belongs to a specific order.
Okay, next we have the index. An index is a structure that improves the speed of queries in the database. For example, if we create an index on the order date, the system can quickly find orders from a specific time without checking the entire table.
Then we have the transaction. A transaction is graph of operation that must all be completed successfully or not at all. For example, when a customer pays, the system of creates the order, adds the order details, and update the stock. If one part fails, every time is cancelled to keep the data consistent.
Okay, and finally we have the trigger. A trigger is an automatic action that happens when a specific event occurs in the database. For example, when a new order detail is added, a trigger can automatically reduce the ingredient stock without manual intervention.
Okay, to conclude, the bakery project, we modeled the main entities, customer, order, product, and ingredient. These are connected through different types of relationship, like one to money and money to money. Primary and foreign case ensures that all the data is correctly linked.
Okay, also the order detail acts as a weak entity to store the products inside each other. Index helps improve performance, transactions, protect the integrity of operations, and Tigris automate important process like updating stack.
These concepts together help create a well-organized, efficient, and reliable database system of managing bakery.
Okay, thank you so much.